Okay, so let's put this information to work. It says find the absolute maximum and minimum values for the function on the given interval. Our given interval is from -2 to 1 inclusive. Our x squared
minus 2x plus 5. So the very first thing I need to do is go ahead and take the derivative of this so that I can get some critical values. So first derivative would be 3x squared. 2 times a half will be 1, so minus x minus 2 plus 0. If I set this equal to 0, fortunately it's factorable, so we'll go ahead and factor. So 3x and x will be my first terms. Now, last term's negative, so I need a plus and a minus. Middle term's negative, I need the bigger product to be negative, so I'm going to put the negative sign here and the positive sign there. Now, because the difference is only 1, I will put the 2 here and the 1 here, and that way the outers are -3, the inners are +2, and when I combine them, they give me that -1 in the middle. I set each factor equal to 0, because if either one of them is 0, that means the product is 0. Subtract 2 and divide by 3 means -2/3 is one critical value, and if I add 1 on this one, 1 is the other critical value. Alright, so we need to test at -2, at -2/3, and at +1. Our critical value also happens to be our endpoint. We're going to put these numbers into our original function. I want actual output values of the function itself. So it would be -2 cubed minus 1/2 times -2 squared minus 2 times -2 plus 5. And that output value is -1. Then we're going to do -2/3 cubed minus 1/2 times -2/3 minus 2 times -2/3 plus 5, and that output value will be 6.4. And these you can confirm with your calculator. Then we have 1 cubed minus 1/2 times 1 squared minus 2 times 1 plus 5, and that output value is going to be 3.5. I'm looking at these numbers, and the absolute minimum value of these outputs is a -1. It's produced by a -2. And the absolute maximum of these numbers is 6.4, and it's produced by the -2/3. So absolute max of 6.4 occurs at x equals 2/3, or -2/3. And we have an absolute min of -1, and that occurs at x is equal to -2. Okay, problems like this you can find page 241, numbers 3 through 86. Now here's a real-world problem. Sound Software estimates that it will sell n units of a program after spending $a on advertising, where n of a is equal to -a squared plus 300a plus 6. Now this works on the interval from 0 to 300, and it says or equal to, so this is a closed interval from 0 to 300, and a is in thousands of dollars. Find the maximum number of units that can be sold and the amount that must be spent on advertising to achieve the max. Now if you remember, this is a second degree polynomial, which means the graph of this is going to be a parabola, and because it's leading with a negative here on the square term, that means it's going to be open upside down, which means it's going to get to a point where you're spending money on advertising and it's actually decreasing the amount of units you sell. Obviously we do not want to throw money away, so we want to figure out where that is. So if we go ahead and take the first derivative, we can get critical values. So it would be -2a plus 300 plus 0. We'll set this equal to 0. Subtract the 300. Divide by the -2. So a is going to be 150, which means our only critical value is 150. We're going to test at our endpoints and at the critical value. Now if we put 0 into our original, -0 squared plus 300 times 0 plus 6, that's 6. If we plug in the 150, negative 150 squared plus 300 times 150 plus 6, that value is going to be 22,506. And if we put 300 in, negative 300 squared plus 300 times 300 plus 6, this is a pair of opposites. They're going to cancel, so it's 6 again. We're only concerned with the absolute max. So then maximum units sold of 22,506 occurs when 150,000, remember this was in thousands, $150,000 is spent on advertising. Don't want to go over that because you're just throwing money away. You're going to lose money. Now for our last example, we have a total cost and total revenue function for producing X items. Cost function is 5,000 plus 600X. Revenue function is negative 1/2 X squared plus 1,000X. This works on the closed interval from 0 to 600. First, we have to find the total profit function. So if you remember, profit function is going to be the revenue function minus the cost function. Okay, so then our revenue function will be negative 1/2 X squared plus 1,000X. From that, we have to subtract the cost function. These parentheses are very important because remember, you're subtracting the entire function. You're subtracting each term, which means you're going to have to distribute that minus sign. So when we go to simplify, first thing we'll do is distribute the minus sign. So it'll be minus 5,000 minus 600X. Combining like terms will be negative 1/2 X squared. 1,000 minus 600 is 400 minus 5,000. Okay, so this is our profit function. From here, what we need to do is get our critical values. So in part B, we're going to go ahead and take the first derivative. 2 times negative 1/2 is negative 1x plus 400. If we set that equal to 0, then x will be equal to 400. We add x to both sides. So we only have one critical value. The average profit function. Okay, let's find the number of items x for total profit. All right, so we found our critical value, which means even in part B now we're still doing our testing. So we'll have x and p of x. We're going to test at 0, we're going to test at 400, and the other endpoint is 600. So back to your original function here. If you put 0 into this function, you're going to lose $5,000. Okay, if we put 400 into this function, then we're going to end up with an output value of 75,000. And then if we go ahead and put 600 into this function, we end up with an output value of 55,000. Okay, so here's your maximum. When you produce and sell 400 items, you will make your maximum profit of $75,000. Okay, your average profit function is given by the profit function divided by x. So it says it wants us to find the average profit function first. So we'll take the profit function and we'll divide every single term by x. So negative 1/2 x squared divided by x plus 400x divided by x minus 5,000 divided by x. So this is now negative 1/2 x plus 400 minus 5,000 over x. Part D says find the number of items for which the average profit is a max. Okay, then we're still on our interval from 0 to 600, but now I need to take the first derivative of your average profit function. Let's fix this notation. Average profit. Okay, so then the average profit function derivative will be negative 1/2 plus 0
This, remember, is going to be 5,000 x to the negative 1 power. So negative 1 times negative 5,000 is plus 5,000. And then your x to the negative 1 minus 1 will be x to the negative 2. So it's really divided by x squared. Let's go ahead and set that equal to 0. If we add 1/2 to both sides, I have 5,000 over x squared is equal to 1/2. This is a proportion. I have two fractions that are equal to each other. So if I cross multiply, which is basically multiplying both sides by the common denominator, which is 2x squared, 2 times 5,000 is 10,000. And x squared times 1 is just x squared, which means then in order to get x equals, I need to take the square root of both sides. When you do, it's a plus minus. However, in the context of this problem, negative items is not an option. So when we take the square root of 10,000, x is just going to be 100. Okay, so then now your values that you're testing would be 0, 100 for your critical value, and 600 for your high value, or the end of your interval. And we're going to test these in the average profit function. So when I put 0 into my average profit function right here, I can't, because this last term, division by 0, is undefined. So this is a DNE, so this is definitely not going to produce the max. If I put a 100 into my average profit function, the output value is going to be 300. And then if I put a 600 into this average value function, the output value is 291.67. So then as far as an average profit is concerned, the maximum number of items would be 100, or the number of items that produces the maximum would be 100, and that average profit would be 300,000. Actually, just $300. This does not say it's in thousands. So max at x is equal to 100, and the max is 300. Okay, problems like this, page 242, 97.